Hi, and welcome back to IV Tutor. My name is Edmund, and in this video, we are going to talk about how to interpret a UML class diagram. And what we have on the screen there is an example of a UML class diagram. And we want to talk about how do you understand what's exactly in this diagram. We're going to do this in two steps. The first thing we're going to try and emphasize on is how do I define all the classes in this UML class diagram. Then in a separate video, we are going to talk about the relationships that are described or indicated or outlined in this UML class diagram. And by relationships, I mean these lines that we see, these asterisk here, what's going on here. We are going to, however, talk about this line here and what it means, right? So a UML class diagram is just there to show you the structure of your classes and how they are related to each other. And like I said in the previous video, and if you haven't watched, please go. We need to understand how to move from a UML class diagram into a class definition for all these classes. And also, given class definitions, you should also be able to do the reverse, which means draw the UML class diagram. So it's a direct translation from the diagram to the classes and from the classes back to the diagrams. Okay, so in this case, I'm not even going to discuss what the question really is. I'm just going to talk about what's happening here. So we're going to then go further and understand what this question was really about and then do the whole question. But at this point in time, I've taken all the context out. I just want you to understand that looking at a UML class diagram, you should be able to define all the classes involved. Right? So basically what you can see here is we've got these 5 blocks that we've got 1, 2, 3, 4, 5. And each block here represents a class, right? So each block is representing a class. In other words, in this case, we are looking at 5 classes. And at the top of each block, we've got the title or the name of the class, right? Or rather, let me just say class name at the top, right? So in other words, this class here is called transaction. This one is called product. This one is called food product. This one is called product list. And this one queue list. Now, 4 of these classes are all classes we are going to introduce. But a queue list is a predefined class. It's a class that is part of the Qt framework, right? We are not defining it. It's already there. We just need to use it. And you should also remember that most of the classes we use in Qt all start with a Q, right? Don't ask me why. It is what it is. So we need to understand. So given these 5 classes, how do I move from this diagram and end up with the actual class definition for all these 5 classes? And the first thing is to understand what each thing in this diagram represents. So I said each block represents a class. So in other words, we've got these 5 classes, and you're going to realize that each block has 3 sections. 1, 2, 3, 1, 2, 3, 1, 2, 3. Even if it's empty, the convention in this case is to just include the 3 sections, right? So the top section, I've already said it, represents the name of the class. The second section represents your member variables, right? In other words, you can also say your data members or your member variables, right? And the third section represents your functions, right? That is what these 3 sections represent. And the other thing that I also want you to notice here is that before each member variable or function, there is either a hyphen or a plus, right? I'm now referring to what we can see here, right? These access modifiers here. It can be a hyphen, it can be a plus. So our access modifiers here, we've got 3 options, right? We have a hyphen, we have a plus, and we have a hash. In this diagram, we don't have a hash, but we'll talk about it in the next couple of examples. A hyphen simply means it's private. A plus means it's public. And a hash means it's protected. These are the 3 access modifiers we are going to be dealing with when defining anything in a class. So before you define a function or a member variable, the question is, where does it go? Is it private? Is it public? Or is it protected? In this whole diagram, we are only dealing with private and public. But we are going to talk about protected and what it means for a member variable to be protected. For those of you who are coming from the previous module to this one, which is course 1512, you would understand what protected really is because it was part of that course. But anyway, let's stick to this. So in other words, you see that mostly member variables are always private, which shouldn't be a surprise by now if you've dealt with classes before. But it's not uncommon to see one or two member variables that are public, or to also see functions that are private. For example, you can see that in this particular case, we've got a function that is private, and it's called code used. That is the name of that function, and it's private. Why? Because we can see here, we've got a hyphen. So that's a private function. We unfortunately or fortunately do not have public member variables, but sometimes it's also common to have a public member variable, especially if it's a constant, or sometimes if it's static, right? Right. So we'll talk about those things later on. So now, if we come back to these classes, right? How do you understand how to then define all these member variables or all these functions, right? One thing I want you to understand whenever you're dealing with classes, which I've seen some students getting confused about, is the fact that whenever you introduce a class, you have introduced a type. A class represents a type. When I say a type, I mean variable type. For instance, an integer, or a QString, or a double, or a QDate, any type you can think of. So the moment you introduce a class, it means you have introduced a new type, which means you can actually start defining variables of type transaction, for instance, or variables of type product, for instance, right? So that is important for reasons I'll explain in a few minutes, but it's a thing that I always want you to understand whenever we talk about classes. So in this case, we've got 5 classes, right? Inside product, you are defining a list of type transaction. Now, a queue list is a special list. I don't want to talk much about a queue list in this video, but whenever you define a queue list, you have to specify the type. Like, is it a queue list of integers, or a queue list of queue dates, or a queue list of doubles, whatever it is. In this particular case, we are dealing with a queue list of transaction because we have introduced a type called transaction, which means when implementing these or when defining these classes, there is a certain order that you want to use to make your life much easier, right? So in other words, I would start off by defining transaction. Why? Because I am going to need to use a transaction inside product. So I would define this class first. Then I can define product next. After that, you are free to define food product next. I would not define food product before product. Why? Because of this relationship that we are seeing here. This triangular arrow here means that it's inheritance, which is the reason why we are having this lesson, right? It's inheritance. And inheritance is depicted by this triangular arrow. It doesn't matter the direction. In other words, you can draw it as A, then you draw it like that, then you go B. It simply means A is inheriting from B, right? And that is exactly the same thing happening also here. Product list is inheriting from a queue list of type product. So I can go ahead and define my product list class. Now, this one you don't define. Remember, this is already a predefined class. In other words, it's part of Qt already. We don't have to introduce it. It's already there. So it will make sense to define your classes in this order, right? Because in order for you to define food product, it has to inherit from a product, which means a product or the product class must exist so that we can inherit from it. For us to implement or to define this transaction data member here, we have to make a queue list of type transaction, which means a transaction class has to exist so that we can refer to it and make a queue list of variables of type transaction in here. Now, let me just explain a few things in terms of defining your variables and implement or defining your function. Sorry, we are not implementing yet. All right, so I'm going to go deep into how to define these variables or how to implement, how to define these functions in a short while. But before we go further, since we mentioned inheritance, product is the parent of food product, or sometimes we can say product is the base class of food product. Now, I don't want to use the words parent and child when referring to inheritance because we're going to need to use them when we go into creating GUI, creating graphical user interfaces with Q objects. So to avoid that confusion between what's a parent child, what's a base class and subclass, we are going to stick with the words base class and subclass when talking about inheritance, and we'll use the words parent and child when talking about Q objects. For now, don't worry what those things are. We'll get there, right? So when there is inheritance, we are saying that product is the base class and food product is the subclass, right? So by inheriting from food product, we are saying food product is a specialization of a product. Or we can say a food product is an extension of a product, right? So we are saying we've got a product. Yes, we are here. We are happy. But on top of everything that we have in product, we want more items. We want to specialize or we want to extend a product. So by inheriting, you are saying a food product has all of this plus this. So in other words, if we are defining a food product without product, we would have to copy paste everything here and put them in a food product. That is inheritance. So in other words, in other languages like Java, you would use the word extends, right? You are extending a class, right? So by inheriting from a class, you are saying, I am everything that the base is, but I'm a little more special because I've got a specific way of doing something, or I've got more things to do that the base does not do. So a subclass is larger, so to speak, than the base because it has more items. So I'm going to repeat here. The subclass has everything in the base plus everything that's here, but you don't repeat what is already in the base. Okay, so we are going to talk about, well, so why then do we have the cell function here and the cell function here? But this is not for this video. We'll talk about that in the next in the next coming videos. But for now, we just want to look at this and say, okay, fine. These are our two classes. How then do we define all these functions and define all these member variables and define all these functions? How do I define these things? Because you don't have to understand that this is the base class, or in this case, you have to because it's inheritance, but you don't have to understand why we have the same function repeated twice for you to define these classes, because you are defining these classes exactly as they look here. So there's no much thinking. You're simply saying, okay, here's a class called food product. It's inheriting from product. It's got two data members and all these functions. You define them as it looks here. And that is the reason why I said moving from a UML class diagram to a definition is a one-on-one translation. You're not even interpreting, just translating as it is from diagram to code. And I said, given code, you should also be able to translate from code back to the diagram. Okay, so let's clarify a few things that I want you guys to understand before we start defining these functions. The first thing is, how do you define the functions, right? We said plus means it's public, which means it goes under public. The name of the function is cell. Now, if there is nothing after the closing bracket, it means it's a void function. So you go void, then the name of the function. Now, I want you to realize that with your arguments or with your member variables or your function arguments, it's always in reverse. You start with the name of the argument or the name of the variable and then the type, separated by a colon, right? If it's many of them, then there's a comma, then another pair, comma, another pair. So it's always name of variable, colon, type, name, colon, type, name, colon, type. That is how you define your member variables or your arguments in a UML diagram. So you can see here, name, colon, type, name, colon, type, name, colon, type, everywhere. But when you write these in code, you then start with the type and then the name. If you start with the name and then the type, your compiler is going to be swearing at you, right? It's a syntax error. We don't code like that. So you start with your type and then the name of the variable. So this here would look like that. Let's look at this function, toString function. Now, this one has no arguments, open, close, but after the closing bracket, there's a colon and then QString. Now, this means that your function returns a QString. Now, there was nothing here, which is why we said it's a void function because there's no return type, therefore it's void. And in this case, we are saying this toString function returns a QString, and therefore you would then define your function like this, QString toString. Done. Okay. Then we've got, in this case, a QList of type transaction, and it's called m_transactions. Again, you start with your type QList transaction, and it's called m_transactions. Now, one special type of variable that you must always be careful about is when they use caps for the name of the variable. It's just a naming convention. It doesn't really mean that you have to do it, but more often than not, is a convention. Whenever you've got a constant variable, it's named in capital letters. So this simply makes it a constant. The question would also, in most cases, highlight that for you, right? Otherwise, it's still int discount. Now, a constant variable is initialized and is defined and initialized in one go. You don't define a constant variable and then leave it with no value because there's no way to then set it. So in this case, I'm just using an example of 10. I don't know what it should be. We have to read the question to understand what was the requirement for this constant variable called discount. So we'll go there in our next video. Then we've got here, inheritance. How do I inherit from a class? So you would go class, food product, then you put a colon to show that you're inheriting publicly from product. So it's always colon public product. Now, this means I'm inheriting publicly. Can you also inherit privately? Yes, you can. But for the whole duration of this course, we don't deal with such scenarios. So I'm not going to go into inheriting privately and all of that. So we always just go public and then the name of the class. That's how you do inheritance, which is the same thing also happening on this part of the diagram. Product list is inheriting from a Q list of type product. But these are product pointers because there's an asterisk here. Sorry, my typo, this should be a capital letter L because it's a Q list, right? Remember, Qt is case sensitive, so you have to be very careful. But you do your inheritance exactly like that. What is missing here? The word public. If you do it like this, you will say it's fine until you try to use a QList function. So here we are missing the keyword public. So it should be class product list colon public QList of type product pointers. Now remember, inside the QList angular brackets, you can put any type. If it's an integer, you put an integer. If it's a product, you put a product. In this case, it's a list of product pointers. Why are they pointers? Because they are pointers. Whoever designed this solution wanted to use pointers, and they used pointers, right? So we won't go much into why are they pointers. We just need to understand that they are pointers. That is all that's critical. It's a Q list of product pointers, which means in this list, you only put pointers of type product. Remember, you can have a pointer of type int, a pointer of type double. Here we have a pointer of type product. So basically, that is how you interpret a UML class diagram. Now what we need to do now is to quickly go into our IDE and implement all these classes, right? That is exactly what we want to do now. Right, just give me 1 second, just to confirm something quickly. Yes, let's do this right now. Okay, so let's go into Qt. We know that this question is a console application because the question that we are trying to do here, which we'll look at later, says it's a console application. So I'm going to create a new project here. It's a console application. I'm going to call this project example 1. Remember, you can go and download this code in your course resources under self-study video resources. That is where this project is going to be. And you can have a soft copy version of what we are about to do right now. So I'm going to go next, finish. Now, if you are doing your work inside Qt, you can use shortcuts, right? Like adding your classes and all of that. But if you are still very new to programming, I would advise you to just do things manually a little bit so that you get used to how to write the code and rely less on the IDE, because come exam time, the IDE won't be there for you, right? So it's very crucial for you to understand exactly how to do what we are doing. So let's go back to our diagram. We want to start by defining transaction, which is this guy here, number 1. And I'm going to do a direct translation of this transaction to from UML diagram to our code. Our class is called transaction. So I'm going to just go and right click here, add new class, choose. I'm going to call this class transaction, finish. And now it creates my header here and it does my source file here. Now it always includes a constructor every single time. I'm just going to ignore it and leave it there. Otherwise, as much as our class is concerned, we don't have a constructor here, right? It's empty. But I'll just leave this one there, right? I'll just leave it there. Now let's go ahead and define these 3 member variables: int m underscore number of items, double m underscore price per item, q date, m underscore transaction date, and then a public function q string to string. So I'm going to be looking at that diagram on the other screen and just define my variables here. Don't worry about these here. If you're coming from course 1512, you would know what this is. If you don't, for now, let's not bother about that. If you have any questions, you can ask me in our live classes, right? But I'm going to ignore these things. Now, let's quickly, we said our member variables are all private, like as we can see in this diagram, right? They are private, which means they go under private. So let's go private. Our first is called m underscore number of items. It's an integer. There we go. And I'm just using exactly the same variable names that I've been given inside this diagram. And I would recommend that you also do, just so that you don't confuse yourself forgetting what you called it. Just do it as per this diagram. So I would call it m underscore number of items, and it's an integer. That is what I've done. And there it is. And the same way, I'm going to do the rest. So we've got double m underscore price per item, and we've got q date, and this one is m underscore transaction date. But now in this case, for us to use a q date, we have to include q date. So whenever you use these Qt types, you have to include them here, right? And now you can see it's happy. So the coloring also helps you to identify if there's a syntax error, because if I, for instance, do a mistake and do it comes to letter I, you can see that the coloring there is sort of off. It should be like, you know, it tries to help you through colors that something is just looking wrong, right? So, and then you change that to that, and now it's happy. Now, and our functions, we've got a function called QString, which returns a QString. So I can just go QString, to string, which returns a QString. And thus, and once I've done this, I have defined my class according to this diagram. Everything done. Now let's move on to product, shall we? Right? Exactly as it looks there. But now inside product, I have to use I need to use a transaction. I'm defining a list of type transaction, which means I have to include my transaction class in product. How do you do that? Which means let's just add a new class first. Let's go add new class. This one is called products, and here under private we've got, I'm just going to type these exactly the same as they look here. I think we've already talked about it. QString m_description, int m_supplier code. So I'll just go through the list. So we've got a QString, which is m_description, and obviously we should also include QString, right? Okay, and let's have int is m_supplier code. We've got int m_ number of items. We've got a Q date, m_date supplied. Now I should also include a Q date, but because I'm going to include the transaction which already has a Q date, I might choose not to. But again, it doesn't hurt to do it, right? So if you want, you can still include a Q date here. Your compiler will handle that conflict for you, and that's the reason why we have these things here, right? But I'm not going to focus on that. The next one that we have is double price per item, right? So I'm going to go double price, it's m_price per item. Then we have int m_product code. We have QList of type transaction. Now this is not heavy because we don't have a transaction. It doesn't know what a transaction is. So if you try to build, it would say undefined type transaction. I don't know what a transaction is. So what we need to do is to include our transaction class here. Now for your classes, you have to use double quotes. And for Qt classes, you use angular brackets. Your classes, double quotes, right? And now you can see it's happy because now it knows what a transaction really is. And I've defined all my member variables according to this diagram, right? Now let's go and introduce all our functions. And as we can see, these are all under public. The first function is called product, which is the same name as our class. In other words, it's a constructor. Remember that the function that is the same name as your class is referred to as a constructor. This is all again coming from your previous module, but it's here. So with a constructor, you don't put the keyword void. No, you don't. You just write it as it is, right? So we've got our constructor here, which takes 1, 2, 3, 4 arguments: QString D, int sc, int n, and double p. Remember the notation type. I mean, in the UML diagram, it's name and then type, but in the code, it's type then name. So if I then write these arguments exactly as they look here, I am saying here's my constructor. It was put there for me already, so I'm going to use it. The first argument is a QString D. The second one is int sc. Third one int n. Fourth one double p. These are all my arguments. They look like this, and I'm done. And remember, with a constructor, you don't put void. No, a constructor will never ever return anything. So you don't need to put a return type behind your constructor. A constructor is simply the name of the class. Then you put your arguments and you're done. Now let's look at the next function, the cell function, which we've just discussed. We said it's void cell int n, right? Then the next one, int get supplier code. Next one is void set product code. This one has one argument. Int pc. We've got void. No, this one is int get product code. And then we've got the string function. We've got the remove all function. And lastly, we've got the is expired function. Okay, So these are all the functions that we have according to this UML diagram, exactly as they are, right? I've just copied them. And again, it's a one-to-one translation. I'm not doing anything fancy. I've not introduced any new logic. It's exactly as it looks, right? Next class, then number 3, food product. So let's go back to our solution. Let's right-click, new class. This one is called food product. Let's finish. And then again, I'm just going to do the first thing that we need to do, inherit from product. Now for me to inherit from product, we have to include product. So let's go #include product h, there it is. And now I can now do something like :public product. And that is inheritance taken care of. Otherwise, we continue exactly the same way. Under private, we've got our data members here. We've got our constant int discount. I'm not quite sure what it should be set to. I'm going to make it 10 for now, but we'll come back to it. And then we also have a Q date, code M, sell by date. And we are done with our arguments. Then we go back to the constructor, and again, exactly the same thing. All the arguments are here. QString D, int sc, int n, excuse me, double p, qdet sbd. So I'm just going to type in as they are here. So we have QString D, int sc, int n, double p. Remember, you can go on the next line if you want. It doesn't break. Then we've got qdate sbd. Then the next function is obviously void cell, which takes an integer, and the next function is qstring to string, and the last function is bool is expired. So again, we have put these functions exactly as they look here. All right. And last but not least, we need to then go to our final class, which is product list, right? So exactly as it looks, we go back to our Qt, we right click, add new class. And this one is called product list. There it is. And in our product list, we have only functions, right? So we've got only functions, no member variables, just 4 public functions and 1 that is private. So I'm going to start with the private one just because I want to. There's no reason. So under private here, we've got a function called, it returns a Boolean. It's called code used, and it takes an integer PC, exactly as it looks here. It returns a Boolean, takes 1 argument, it's called code used. Now let's do the inheritance. So here for the inheritance, we need a Q list and we need the product for us to be able to use these 2 classes here. So let's go and include those 2. Let's go #include Q list and also #include product. Then our inheritance is usual, :public Q list product pointers. Done. That's inheritance as explained before. Now we can go ahead and do our functions. We've got one that returns an integer. It's called add. It checks product pointer p, right? Where am I getting that? Where is that coming from, right? Where is that coming from? So here we can see p is the name of the argument. The type is a product pointer, right? You see that asterisk that is here. Perfect. So let's do the remaining 3 functions exactly as they look there. We've got void cell, int PC, int n. We've got void remove int PC, and lastly we've got void delete all. So in this case, we are done with all the 5 or the 4 classes that we have defined, which is transaction, product, food product, and product list in our example. And I hope that makes a lot of sense. You should actually try and copy this UML class diagram or find a different one and try and define all your functions according to your UML class diagram. What we don't have in this diagram are abstract classes. We'll cover that in the next example. Otherwise, in the next video, we're going to talk about how do you then implement your functions. My name is Edmund. Let's see you again in the next video. Cheers.